I wanted to give you a little bit of mixed practice using StatCrunch, and by that I mean mixed that it could be proportions or means and you have to determine, and StatCrunch being you don't have to do it by hand, just use StatCrunch to do the calculations. So here are the two questions, and I would like for you to just press pause right here, read through the questions yourself, and then try both questions. The data set for the coffee machine is in your Unit 5 data set. Again, go ahead and try both questions completely. Again, you don't have to do the values in by hand, just use StatCrunch, and then press play to move on to the next slide to check your work. So let's look at this first question together. This is a man that's claiming to have ESP, so he's saying he can choose a suit more often than the typical person would. So let's talk about a couple of things here. Is this the means question or proportions? Because we're talking about how often that he's able to correctly detect the correct suit, we're dealing with a proportion. And so in a proportion, the conditions I check are independence, 10%, success, fail, and randomization. I've checked them there for you, and everything is met. Remember that because this is proportions, we're not doing nearly normal, we're doing success, fail. And again, I'm able to do a 1 proportion z-test in interval. Then, where did I come up with my hypothesis? 25%. Where did that number come from? Well, if the man does not have ESP, then remember there's 4 suits in a deck, and you're going to be correct on average 1 out of 4 times, okay? Because there's 4 suits and only 1 of them is correct. So the average person would be correct 1 out of 4 times. So that is what I'm assuming, is that nothing has changed. This guy is full of it. There's no way he's going to correctly detect more often than 25%. So that's the alternative hypothesis, is that P is going to be greater than 0.25. He thinks he's better than normal, that his ESP gives him a better insight into what the suit will be. So now I have to actually do the calculations in StatCrunch. So again, this is a proportions question, so I'm going to go to Stat, and I'm going to go to Proportion Stats, and I'm going to go to One Sample with Summary. And what I need to do when I'm doing One Sample with Summary is I need to do the number of successes when he got 24 successes out of all 52 cards. So he went through the 52 cards, 24 were successes. And the question is, does he have ESP? So I'm going to do a hypothesis test first, and I'm going to then look at P being 0.25, and my alternative is that it's greater than 0.25, and I'm going to compute, and I have a really, really low p-value, okay? And so again, if you have a low p-value, what does that tell us? That we should be rejecting the null. But I want to do both the test and the confidence interval. And remember, this is a one-tailed test. And in a one-tailed test, I take 1 minus 2 alpha. Alpha is 0.05. So 1 minus 0.05 would be 1 minus 0.1, or 90%. So I'm going to do the same thing, stat, proportion stats, one sample with summary. And this time I'm going to choose confidence level and do 0.9. So I'm still going to use the 24 here and the 52 here with a confidence level of 0.9 and compute. So these would be my 2 outputs in StatCrunch. And again, I could have done this by hand, but just for the sake of time, we're doing just in StatCrunch. So what's my conclusion based on these values? My p-value is exceptionally low, so I'm going to choose to reject the null hypothesis. There is sufficient evidence that the alternative is true, and the alternative is that the man is correct more than he would be by guessing. Or you could say the man is correct more often than 25% of the time. I'm 90% confident, again 1 minus 2 alpha, that the man will choose the correct suit between 34.8% of the time, that's from here, and 57.5% of the time. Since this interval does not contain the null hypothesis of 0.25, meaning 0.25 is not between those values, then it basically agrees with our result to reject the null. Again, let's look at our second example. This one I actually need a data set in StatCrunch for. It says a coffee machine dispenses coffee into paper cups. Are we, dealing with a difference in the 10 ounces we expect? I check the conditions, and these are the conditions for a means question because we're looking at the average amount of coffee, not a proportion, but an average amount of coffee. So I check my conditions, they all work out. Again, if I had to do the nearly normal condition because I didn't show that on your slide, I would go to graph and either histogram for coffee, and that looks fairly unimodal and symmetric. If I was concerned about that, I would go to graph and QQ plot for coffee, and I would get something that looks okay. See how it follows the pattern of the red line. So I feel okay about it being nearly normal. Hypotheses, I'm looking at, is there a significant difference between the 10 ounces that we expect? So remember, the null would be not equal to 10. And it's a means question, so I'm using mu instead of p. And then I have to do all of my calculations in StatCrunch. So I'm going to go to stat. And in this case, this is a means question, so I'm not using proportion, but t-stats, one sample with data, because my data is already in StatCrunch. I'm choosing coffee, hypothesis test. I'm assuming mu is 10. I'm testing whether it's not equal to 10, and I'm clicking compute. So that gives me a p-value of 0.0024. And then I'm also going to go to stat, t-stats, one sample with data, same exact thing, still with coffee, and this time, remember, this is a two-tailed test, so I just take 1 minus alpha, assume alpha is 5% unless they tell you otherwise, which means my confidence level is going to be 95 this time. 1 minus 5% is, 100% minus 5% is 95%, and I'm going to compute, and that gives me my interval. And so my solution would be that given a p-value that is very low, I reject the null hypothesis. There's strong evidence that the mean volume of coffee dispensed is different than 10 ounces. Where did I get that? That's the alternative hypothesis. So I'm either saying I support the alternative or I don't. I'm 95% confident that the true mean volume of coffee dispensed is between 9.75 ounces and 9.93 ounces. 10 does not fall in that interval, so it supports rejecting the null hypothesis.